take a breath. Tomorrow's exam won't ask you a single thing you haven't already learned across this course. Every decision rule, every keyword, every number is already in your head. Today isn't cramming new material. It's a warm-up lap, so your recall is firing the moment you sit down. Stack lessons here. Stick around, this one pays off. By the end of this pass, every high-yield decision rule and numeric threshold from the whole Solutions Architect Associate course will be fresh and ready to fire. This is the final beat of the course, so there's no new teaching here, just a fast sweep across all 4 domains to prime your memory before you walk in. Here's how this works. 1 idea per screen, moving fast, nothing new. We'll sweep through every decision rule, keyword map, and numeric threshold worth locking in. First the 4 domains in order, then the raw numbers the exam quotes, word for word, and finally the technique for taking the test itself. Don't strain to memorize. Just let it wash over you and confirm what you already know. We start with secure architectures, the largest slice of the exam. If any domain deserves your freshest attention, it's this one. Here come the core rules. When the scenario asks how to give an EC2 instance access to an Amazon Web Services service without hard-coding keys, the answer is always the same. Attach an IAM role through an instance profile. The temporary credentials rotate automatically and the SDK picks them up on its own. No stored access keys, ever. The IAM documentation puts it plainly. An explicit deny in any policy overrides an allow in every other policy. So when you see a user with full administrator access who still gets blocked, stop looking at their allows. A deny is hiding somewhere, in a permission boundary, an SCP, or a resource policy. One deny anywhere, and it's over. Service control policies set the ceiling. They restrict, they never grant. An SCP applies to every principal in a member account, including root, though SCPs do not restrict the management account. A deny there blocks the action no matter what IAM says. But an SCP allow on its own grants nothing. Think of the SCP as the venue's capacity limit and the IAM policy as your actual ticket. Both have to say yes before you get in. Security groups stored at the instance level, and they're stateful, like a doorman who remembers who he let in and waves them back out automatically. They only support allow rules. Network ACLs stored at the subnet level, and they're stateless, like a turnstile that demands a token in both directions. And here's the one that decides questions. When you need to block a specific malicious IP range, only a network ACL can deny. A security group cannot. Because network ACLs are stateless, they don't remember outbound requests. So when a server sends a reply, that reply comes back on a high-numbered ephemeral port, somewhere between 1024 or 65. That range varies by operating system, but 1024 to 6535 is the recommended catch-all in exam answers. If your outbound rules don't explicitly allow that range, the responses vanish silently. The requests arrive fine, but the replies never make it out. Setting default encryption to server-side encryption with KMS is not enforcement. A caller can still override it on upload. To actually guarantee it, add a bucket policy that denies any put object requests missing the KMS key ID. That deny statement is the real lock. The default is only a fallback. Now, resilient architectures. This is availability, failover, and disaster recovery, and it hinges on a handful of distinctions that look almost identical until one word separates them. Here's a distinction that catches a lot of people, so let's lock it in. Multi-AZ keeps a synchronous standby for automatic failover, and that standby is not readable. It's a spare tire in the trunk. They're only for emergencies. A read replica is asynchronous and readable. The second car you drive every day to offload read traffic. When the scenario says reporting or read heavy, that's a replica, never the multi-AZ standby. 3 load balancers, 3 keyword triggers. When you see HTTP routing by path or host, or a WAF, a web application firewall, incognito, that's the application load balancer at layer 7. When you see UDP, a static EP, or preserve the source IP, that's the network load balancer at layer 4. And when the scenario drops in a fleet of third-party firewalls or inline intrusion detection, that's the gateway load balancer, using Geneve encapsulation, the protocol on port 6081, to pass traffic through transparently. The 4 disaster recovery tiers ordered by recovery time and cost. Backup and restore is the cheapest, with recovery measured in hours. Pilot Light keeps your core data replicating while the app servers sit switched off, so recovery is tens of minutes. Warm Standby runs a scaled down but live copy, ready in minutes. And Multi-Site Active runs full traffic in more than one region at once, with recovery in seconds. The exam gives you the RTO and RPO targets, and you name the tier. Route 53 routing policies map straight from keyword to answer. Weighted means splitting traffic for an A/B test or a blue-green migration. Latency routes to the lowest round-trip region. Geolocation is strict geography, so EU users stay in the EU for compliance. Failover is active-passive with health checks. Geoproximity is location plus a bias style that shifts traffic between resources. And multi-value answer returns up to 8 healthy records for client-side selection. On to high-performing architectures. This domain is really one skill repeated, matching the workload to the right storage, the right database, and the right cache. When a scenario demands microsecond read latency on DynamoDB, the answer is DAX, the DynamoDB accelerator. It's a fully managed write-through cache that takes reads from milliseconds down to microseconds. Elasticache would technically work, but it's the wrong answer here. DAX is the DynamoDB native cache, and microsecond plus DynamoDB always points to it. The storage triangle. EFS is a shared NFS file system that many Linux instances mount at once, elastic, and spread across zones. EBS is block storage for a single instance in one zone with sub-millisecond latency, the choice for a boot disk or a database volume. And S3 is object storage over an HTTP API unlimited scale with a 5 terabyte cap on any single object. Shared file goes to EFS, a volume goes to EBS, and objects go to S3. Amazon FSx is Amazon Web Services' fully managed file service, and it comes in 4 variants, each with its own keyword trigger. A Windows share over SMB, the server message block protocol, with Active Directory points to FSx for Windows File Server. High performance computing or machine learning training with S3 integration points to FSx for Lustre. A NetApp migration needing multiple protocols at once points to FSx for NetApp ONTAP. And high performance Linux with ZFS, a high reliability file system, snapshots points to FSx for OpenZFS. Local versus global secondary indexes. An LSI keeps the same partition key with a different sort key, must be created when you create the table, and can give you strongly consistent reads, but it's capped at 5 per table with a 10 gigabyte item collection limit. A GSI uses any keys, can be added anytime, but is eventually consistent only. The 2 things that decide questions are creation time and consistency. The DynamoDB docs are exact. The maximum item size is 400 kilobytes, and that includes both the attribute names and the values. When a payload won't fit, the pattern is to store the big object in S3 and keep just the S3 key in DynamoDB. 400 kilobytes is a number the exam quotes directly. 3 ingestion services, 3 signals. Kinesis data streams gives you multiple independent consumers, replay, and ordering within a shard, with retention from 24 hours up to 365 days. That's the one when you see multiple consumers on the same data or a need to rewind. Firehose just delivers to S3, Redshift, OpenSearch, Splunk, HTTP endpoints, and more, with no replay and no code. And SQS decouples with 1 consumer per message, retention capped at 14 days. Last domain, cost-optimized architectures. Same designs you already know, just built to spend less. A few decision rules cover most of it. The compute pricing models. Spot instances give you up to 90% off for fault-tolerant batch work, with a 2-minute interruption warning. Reserved instances give you up to 72% off for a stable, predictable workload on a specific type over a 1 or 3 year term. Savings plans commit dollars per hour and flex across EC2, Fargate, and Lambda. When the scenario needs flexibility across families or regions, reach for a savings plan over a reserved instance. The S3 minimum storage durations in ascending order. Standard infrequent access and one zone infrequent access both hold you for 30 days. Glacier instant retrieval and Glacier flexible retrieval both hold you for 90 days. And Deep Archive holds you for 180 days. Delete before the minimum and you're still charged for the full period. So these thresholds directly change the cost math. The Glacier retrieval times. On flexible retrieval, expedited is 1 to 5 minutes, standard is 3 to 5 hours, and bulk is 5 to 12 hours. On Deep Archive, standard is 12 hours and bulk is 48 hours. Bulk retrieval is free for flexible retrieval. For Deep Archive, bulk is the lowest cost tier but is not free. A per gigabyte retrieval charge still applies. Whenever an instance in a private subnet needs to reach S3 or DynamoDB, reach for a gateway endpoint first. It costs literally nothing. No hourly fee and no data charge. Route that same traffic through a NAT gateway and you're paying 4.5 cents per gigabyte for no reason. For S3 and DynamoDB from a private subnet, the gateway endpoint is almost always the answer. Quick breath and a recap of all 4 domains. Security gave you the role for EC2, explicit deny winning, the SCP sealing, and security groups versus network ACLs. Resilience gave you multi-AZ versus read replica, the load balancer triggers, the disaster recovery tiers, and Route 53. Performance gave you DAX, the storage triangle, FSX, indexes, and Kinesis. And cost gave you the pricing models, the S3 classes, and the free gateway endpoint. Now the numbers. These are the numbers the exam quotes word for word. You don't need to derive them, just recognize them instantly when they appear in a scenario or an answer choice. The EBS performance ceilings. GP3 starts at a baseline of 3,000 IOPS and climbs to 16,000. When a scenario demands the very highest block storage performance, IO2 block express is the answer, delivering up to 256,000 IOPS. Straight from the EBS documentation, GP3 includes 3,000 IOPS and 125 megabytes per second of throughput at no additional charge, regardless of volume size. That's the modern default, and it's why migrating from GP2 to GP3 usually cuts costs with no downtime. 3,000 and 125 are numbers worth reciting in your sleep. Lambda defaults to a 3-second timeout and maxes out at 900 seconds, which is 15 minutes. That ceiling is a hard limit you cannot raise. So the moment a workload runs longer than 15 minutes, Lambda is out, and the answer shifts to step functions, an ECS or Fargate task, or Amazon Web Services batch. The exam loves to swap these two, so keep them straight. SQS retains messages for 4 days by default, up to a maximum of 14 days, with a max message size of 256 kilobytes. Kinesis data streams retains for 24 hours by default, extendable to 7 days and up to 365 days for long-term retention. 14 days is SAN-GUS. 365 days is Kinesis. The S3 object numbers. A single object can be up to 5 terabytes. A single put request tops out at 5 gigabytes. So anything larger has to use multi-part upload. Amazon Web Services recommends multi-part once you're past 100 megabytes anyway. And multi-part supports up to 10,000 parts, each between 5 megabytes and 5 gigabytes. Last block, and it might be the most important. How you take this test matters as much as what you know. 3 habits will carry you through. Before you read the scenario, jump to the last sentence and find the goal. Least operational overhead, most cost-effective, minimum recovery time. That qualifier is the tiebreaker because 2 answers will often both work and only the qualifier tells you which one they actually want. It eliminates half the options before you've even read the setup. Then, eliminate. Cross off the options that are at the wrong layer, the wrong service, or the wrong direction. Once you're down to 2 plausible answers, your odds are far better. You have 65 items and 130 minutes, so budget about 2 minutes each. On the first pass, answer everything you know cold and flag the rest. Then come back to the flagged ones. Never leave a blank. The passing score is 720 out of 1,000, and it's a compensatory model, so only the overall total counts. You don't have to pass each domain separately. There's no penalty for a wrong answer, and 15 of the 65 items are unscored pretest questions you can't identify anyway. So answer all 65 as if everyone counts, and guess when you have to. So here's where you stand. Every decision rule you just heard, you already knew. Read the qualifier first, eliminate the impossible, and answer every single question. The numbers are just anchors, and your recall is stronger than you think. You put in the work across this whole course. Walk in calm, trust yourself, and go get it. Let's finish with a quick 5-question warm-up. Question 1. A company runs a critical RDS database and needs automatic failover to survive an availability zone outage. Separately, a reporting team is generating heavy read queries that slow the primary. Which combination addresses both requirements? Option A, multi-AZ for failover plus a read replica for the reporting workload. Option B, multi-AZ only, letting the standby absorb the reporting reads. Option C, 2 read replicas, one for failover, one for reporting. Or option D, a larger instance class to handle both. Run the multi-AZ versus replica rule before you answer. The right call here is A. Multi-AZ handles the failover, and remember, its standby is not readable. The read replica is the readable copy that offloads reporting. 2 problems, 2 features. The standby serving reads option is always the trap. Question 2. Instances in a private subnet constantly read and write to Amazon S3, and the team wants to eliminate the data processing charges they pay to move that traffic. What's the most cost-effective fix? Option A, route through a second NAT gateway to balance load. Option B, replace the NAT gateway with an interface endpoint for S3. Option C, add a gateway VPC endpoint for S3. Or option D, move the instances to a public subnet with an internet gateway. Pause here if you want more time. It has to be C, and here's why. A gateway endpoint for S3 is completely free, no hourly charge and no data processing fee, and it keeps traffic on the Amazon Web Services backbone. The interface endpoint would work, but it bills per gigabyte, so it's not the cheapest. Gateway endpoint every time for S3 and DynamoDB. Question 3. A security team must block a single malicious IP range from reaching every instance in a subnet while leaving all other traffic untouched. Which control can do this? Option A, a security group inbound rule referencing the malicious range. Option B, a network ACL deny rule for the range on the subnet. Option C, a security group but the range removed from the allow list. Or option D, an IAM policy denying the range. Think about which control can actually deny. This one is B. Only a network ACL supports deny rules, and it works at the subnet level so it covers every instance automatically. Security groups are allow only, so you can never use one to block a specific bad IP. Block an IP, think network ACL. Question 4. An application needs single-digit microsecond read latency for a DynamoDB table serving millions of requests per second, with the least application-level cache management. Which service delivers this? Option A, Elasticache for Redis in front of DynamoDB. Option B, a larger DynamoDB provisioned capacity setting. Option C, CloudFront caching the DynamoDB responses. Or option D, DynamoDB Accelerator, DAX. Got your pick? Let's see. If you said D, well done. DAX is the fully managed DynamoDB native cache that takes reads from milliseconds down to microseconds. Elasticache could technically cache the data, but it needs manual cache management, and it isn't the native answer. Microsecond plus DynamoDB always means DAX. Question 5. A nightly batch job runs for roughly 40 minutes, is fully interruption tolerant, and reprocesses from scratch if stopped. Which choice minimizes costs while fitting the workload? Option A, run it on spot instances. Option B, run it as a single Lambda function. Option C, run it on on-demand instances reserved for the night. Or option D, run it on a 3-year reserved instance. Lock in your answer before I give it away. The answer is A. Interruption-tolerant batch work is exactly what spot instances are for, at up to 90% off. And notice option B is disqualified instantly, because a 40-minute job blows past Lambda's hard 15-minute ceiling. That's the qualifier doing the work, and with that, you're ready. Go get it. That's the whole course. If it helped you feel exam ready, like the video and leave a comment with your exam date, and when you pass, come back for the next certification in the Cloud Architect path.